Hello, welcome back. Last time I got started at my new job in China and already got 2 projects done. Sun showers, 19 Celsius, poor air quality, light drone activity. I won't play with solitaire just yet. So I did the fake security camera and the replacement factory module. Please enjoy a game. My daughter is learning programming. She created a simple card game. Would anyone like to try it and give some feedback for her? I put a link on everyone's desktop. Oh, okay, that's the solitaire game. She is interested to become a game developer. Yeah. Wow, Jay, that is both a lot more polished and far harder than I was expecting. Your daughter's managed to design quite the challenging patience game. Maybe there could be an undo function. She says she doesn't think it needs undo because it is actually quite easy once you develop some skill. She really takes after you. Objective, win a game of solitaire. Okay. I could do this. This sounds like Sigmar's Garden. I would rather save this for a moment. Now that you're up and running, I figure it's safe to let you use all the lovely parts we have available to us. Just be warned that not all of them are going to be useful for what you're doing immediately. On you go then. Alright, in order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements, specifications. Requirements means specifications. However, instead of buying one at the market price, I thought we could simply create our own. For this project, you will need to make use of conditional execution. Please continue your study of the language reference. Okay, so this is a great opportunity to take a closer look at that manual that I skimmed over a little bit. Now that I have the context of what the puzzles look like, what the goal is, what the language is like, so I can actually anchor to some of these concepts and understand them better than if I just read the entire thing all at once. The information just would not have stuck as well if I had done that. Alright, so interest stuff. Immigration, simple IO, X, what do they call it again? Simple IO and X-bus, right. Okay, so I know what those are. There's the sleep, yes, I understand. This was the example that I based my thing off. Do I understand all of this? Let's check if I understand all of this code. The plus and minus there. No. No, I don't. So if I were to place this, if I type a plus, hold on, let's just read about this. Let me not play with it in the game, let me read about it. Alright, detect a rising edge and touch. So TEQ, here's what I should do. Let's open this in an additional tab. And just keep this one on language reference. That way I can refer back to that. Where'd my thing go? Okay, there we go. So I can flip back and forth and see the language reference at the same time as the other stuff. Okay, so TEQ. Register or integer. So register, ACK, integer 0. Alright, so ACK is 0. TEQ, hold on, wait, but tell me something. Test instructions. What does the test instruction actually do? Oh, this is, I think I understand. This is like indentation, I think, maybe. Maybe? Because like when you test... First microcontroller reads from the capacitive switch in the high pin P0 and sends either 0 or 1 over X bus every time units. Every time 0, it's touched, sure. Detect a rising edge and touch. Once you test, what happens? Where does it store the result? Does it jump somewhere else? Is that what the plus and minus is? I should probably read a little further. P0, 100, move 1 to X1. Into the X bus. Move 0 to X1. No, okay, so plus is if this is true. So if ACK is 0... No, but then there's another attack here. Move 0, X1. Store touch. Move P0, ACK. Sleep 1. SLX, what's that? It doesn't say. Alright, let's put another copy of this in here. Alright, so let me put this on the left, this on the right. Alright, so I got like my work thing space, my thing I'm understanding, my language reference, that's always there, and then more detailed, possibly. Replace this pane in a language reference section divider. Language reference, here we go, okay. Small versatile set of operations, right, yes. I should not just like super skim this. Let's skim it a little harder. Program written for one member of the family can be reused in any other with few or no changes. See note 1. Not there. Okay, note 1 is somewhere. Programs are assembled from a small versatile set of operations. Each line can contain an instruction. Name, 0 or more operands. Okay, details on the instructions below. Perfect. Power constrained environments and applications. Designed accordingly. In a sleep state consumes no power. That's impressive. Got to consume a little bit. Otherwise, power consumption is proportional to the number of instructions executed. So that's probably... Hold on, I want to know something else. Go back. Go back to one that I've solved. Production cost, power usage, lines of code. Somehow I just kind of glossed over what my axes of optimization were. Production cost, power usage, and lines of code. Okay, so power usage is a thing to think about. So no power when sleeping, but the number of instructions executed. Of course, got it. MCXXXX controllers have varying features, pinouts, and program space. Oh, this is one. This is note 1 right here. Okay. Program space limitations described in the model-specific datasheets. Sure, so this is an MC4000. Also got a bridge, a note, MC6000, MC4000X, not recommended. So I'm given access to everything, the entire parts library, very early on. I'm not supposed to use any of these yet. Probably not involved in the puzzle, maybe some advanced optimization, but let's not yet. Label. Condition, instruction, comment. Got it. Okay, so that's familiar. Label. Condition. So this must be condition, I would suspect. All components are optional. Are present. As long as comment. Loop. Like is 10. Tag 10. Plus. Yeah, so I want to know about the plus. That's why there's auto-formatting. I understand. Right, because indentation actually means something, kind of. Jump end. Move 50x2. Add 1. Jump loop. Move 0 ag. Okay, so I think I'm inferring it's confusing. So like, what I was gonna say is, this does a test, and probably the plus is for true. If ACK is 0, then it does another test. That's what's throwing me off. If ACK is not 0, then it moves 0 to x1. If it is 0, then this also happens. How does it know which else applies to which test? There's no curly braces, there's no... I don't know. Anyway, this will explain it, I imagine. Add 1 jump loop and move 0 ACK. Sure, of course. Alright, so this all looks familiar enough. Any text following pound symbol is ignored. That's a comment. Comments improve developer productivity by allowing the behavior of the code to be described in line with the program itself. That's a way to put that. Alright, label colon. Use the jump targets, of course. By the jump instruction. Is that the only one? Yeah, there's no like jazz or anything here. This is a different language. So yeah, the tests have a different sort of syntax to them. Conditional execution. Okay. Prefix an instruction with plus or minus will cause that instruction to be enabled or disabled by test instructions. Oh, I see. When an instruction is disabled by a test instruction, so it's like a mode switch. It'll be skipped and not consume power. Instructions with no prefix are never disabled, always execute normally. All conditional instructions start in a disabled state. A test instruction must be executed to enable conditional instructions. I see. Yeah. So, example. All right. So, after this line, It enables the plus if it's true, and enables the minuses if it's false, and does the opposite to the others. But then after this instruction, it does the same thing. So like, this plus, this minus, this plus, they know nothing about this previous instruction. They're not attached or anything. It's just a matter of enable one. So there's always enabled, there's enabled when I've just done a test that returns true, and there's enabled when I've just done a test that returns false, is what I think I'm seeing here. That's cool and weird. All right, I can work with that. Registers. So registers varies. Ah, of course it does. Yeah, see, so this one has 4 little yellow things on the right. What's it look like? ACDAT. Yeah, so I get 2 registers there. State power. All right, they probably maybe all have state power. Oh boy, keep going. Okay, so ACK is a primary general purpose register for internal computation. All arithmetic operations implicitly use and modify the value of ACK. So anything that is add sub mul not dist. Not sure what these are. I'll have to look them up. These are obvious. Are they? Probably. Not will change anything that's not 0 to 0. And anything that is 0 to 1. Yes. Add sub mul are obvious. There's no div, I note. So if I want to divide, I'll have to do it the hard way. And integer math only, of course. ACK is primary generator. Right. All arithmetic implicitly use and modify the value. Okay, so add 1 operand, 1 operand, 1 operand, 0 operands. 2 operands. So what are these 2, I wonder? DAT is a second register available on some. 6,000. Okay, so costs 3 Y symbol, 5. Bridge costs nothing. Can be used in most contexts where ACK is permitted. Of course. Right, so the target is the ACK register, but it can read from DAT or an integer or a port or something else. Internal registers, ACK and DAT, are initialized to 0, of course. Pin registers, P0, P1, X0, X1, X2, X3. Yeah, this has more ports on it. This has 2 each side. 1P, 1X. Or sorry, 2P, 2X. Is this 3P, 3X? Move. X0, X1, P0. No, it's 2P, 4X. Got it. Okay, that actually makes more sense, probably. Because otherwise you'd have to have an input and output on the same side. User reading from writing to reading and writing. Other connected devices. Simple I/O or XBus. Refer to appropriate data sheets, of course. Null is a pseudo-register. Okay, so there's a null. Read from null provides 0. Write to null has no effect. Great. Fixed number of operands. Are you sure? I thought some had... No, that's right. Okay. Yep. Fixed number. The instruction has the associated. It must appear following the instruction name. Okay, I see. So you can comma if you really want to, but you don't need to. Just use a space. Sure. Register, or integer. Pin register. I call that a port, but I could call it a pin register, I guess. Label, right, so that'll be the jump. Jump L. It's the only one with an L. Slicks is the only one with a P? Apparently. Okay. Labels these operands must be defined. Integer values, -99 to 99. Nop, move. Here we go. This is what I really want to see. Copy value first operand to the second operand. Okay, so that's always register. Of course, you can't overwrite an integer. Not an L value. Sleep until data is available to be read on XBus pin specified by operand. Got it. Okay, so that's interesting. So wait until data is available, but doesn't a move just block when you use it on something where data is not available? Why would you want to block at any time other than when you're immediately ready to move? Well, no, yeah, no, that's weird. Like, why this instead of... Because, like, register includes pin registers. I don't know. I don't understand why this command exists when you could just, like, move X bus register null, or move it to actually someplace. Like, if you don't want to write it somewhere, then you use null. But isn't that the same? Maybe it's not. Okay, so I don't understand that yet. Alright, arithmetic's pretty obvious. 999, so it clamps. Doesn't, like, overflow or truncate. Adds value, subtract. Those are the same thing, by the way. Add submul. Not. Okay, if 0 start 100. Okay, so not 0 is 100 instead of 1. That's fair. Sure, because a lot of things seem to be based on 100. So, like, the true value is 100, not 1. It's a strange language quirk, but I can get used to it. Isolate the specified digit of the value in the ACK register and store the result in the ACK register digit. So this is actually a decimal piece of silicon. This don't work in binary. It's a decimal computer. That's weird, but okay. I mean, TIS 100 was the same way. It just didn't have anything this specific. Set the digit. Okay, digit get, digit set. Set digit of ACK, specified the value of the second operand. Oh boy, this is going to be something. Yeah, so this is like the equivalent of bit shifting on a decimal processor. In the ACK register. Okay, so 596 to get 0, 6. Okay, this is 0, this is 1, this is 2, of course. Dist 0, 7. 0 equals 7, 1 equals... Okay. So digit set, digit, index from the right to value. Got it. Okay. So test. Conditional execution, page 2. I don't know where that is, but it's probably down here somewhere. Test of the value first operand is equal to the value of the second operand. I was warned that this puzzle is going to require conditional execution. Let's read what I'm doing so I can, like, direct my manual reading appropriately. So there's a button. It's gonna pulse on and off. Pulse is a simple output connected to an electronic device. When button is pushed, generate pulses as indicated in the verification tab until the button is released. So it's something like you hold the button and then a light blinks while you're holding it. Yes, it's exactly that. Okay, got it. Alright, I definitely know enough to write that program already, but I'm going to finish reading this instruction description so I know what I'm doing. A is equal to B, plus enabled minus disabled. Why is this italic and this normal? Weird. Is not equal to B, Right, and this can compare to more than just the main register. Okay, right, so it's anywhere in this zone that I want to put my cursor if I want to drag it. Okay, so on the registers. I was going for this corner, but it was awkward. Okay, got it. That's not in the manual. Probably. Okay, test equal, test greater than, test less than. Okay, and this is compare, CMP, whatever you want to call it. Greater enabled, equal both disabled, less disable enable. Okay, sure, yeah, so you compare two numbers, and the plus is enabled when it's greater, the minus is enabled when it's less. Got it. That's going to be a complicated one that I suspect I will not find myself using very often. High performance microcontroller. Okay, well that was the language reference. That covered all of these. I know what all this does. So this is wait until input is available on an X-bus pin. Or possibly a simple I/O also. That's sleep. Yes, okay, I know what all these are. These are not instructions, those are registers. ACK, DAT, P0, P1, X0, X1, X2, X3. Oh, I guess that's a complete listing, so never more P's than that, never more X's than that. Okay, so am I ready? Button is a simple input connected to a button. So, I imagine... I don't think that's what I want. Oh, wait. So that's... Okay, so now let me look back at the this test program. This actually... Touch activated light controller. Yeah, this is almost the same program as what I'm writing, but it's a little different. Alright, so in any case, I want P0 to connect to the button. I want another... Do I want another microcontroller? Probably. This is unlikely to be enough instructions, but let's see if it is. So, I'm going to read the state of that. Well, now, hold on. No, let me read this again. So this uses two microcontrollers. So I need like a... If I used the MC6000, I could use DAT to store the state of the blinking light. Okay, there are a lot of ways I could do this. Like any programming problem, of course. So I need to know the state of the button. It'll be 0 or 100, presumably. Yes, exactly that. So on rising edge, I immediately want to output 100 to pulse. Then until falling edge, I need to alternate between 0 and 100. So I definitely need another register here. So if I can do it all in this one, oh hey, this will store more lines of code. If I can do it all in this one, then that's cheaper than using two MC4000s. And I suspect I might be able to. Alright, so DAT starts at 100. Okay, it's the other way around. Move 100, DAT. Boy, this font's tiny. I wish I could make it larger, but that's how it's going to be. Move 100 DAT. Okay, so this is going to be my output value. Yeah, okay, I see exactly how I'm going to do this, right? I think so. This will be a little bit power inefficient, I think. Yes, 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 I'm still typing. Shh. Be quiet. I'm not done typing yet. Okay, so here I would want, let's see, can I okay, so tab does that. So I need to space indent. Really? Who space indents? So if it is, this is loop, by the way. Loop, move 0, P0, ACK. Okay, so plus... Oh, well, I haven't done a test yet. Tech 0. What? Tech ACK 0. So if it is 0... right, I need the pluses here. Yeah, this is different flow control. This is going to be a mess, but I'll clean it up afterward, or not. Let's just see if I can get my thoughts out here. Right, so if it's not... P1 connects to this. I think this would be more pleasing if I moved it like that, so I could read the name, and also it'd be more pleasing if it were centered. There. Okay, and also it can be properly centered. There's no point to what I'm doing, but, well, other than making it look nice. There. Okay, so move that P1. Not that. Okay, so I don't know what I'm doing with the indentation. Maybe nothing. Oh, I can't not that. Okay, so switch dat and ac then. I can only not ac. Alright? So dat is where the state of the button is going to be stored. Tech dat 0, sleep 1, jump loop, move ac P1, not. So not is just, yeah, not is just not. Okay, so it inverts the state of that, and no, hold up. This one wants to jump back to start. Okay, start, move 100 ac. Okay, yeah, so this is the first output that's going to go out. This is my main loop. I check the state of the button. If the button is no longer pressed, or is currently not pressed, then I sleep for 1, and I jump back to the start, and I get ready for outputting again. Yeah, so like, I'm not storing the state of the button really, I'm just reading it and immediately acting on it. I'm only storing the state of the next output, and I'm resetting it whenever I read the button as 0. So yeah, this is not power efficient, but it's fine. Okay, so right. Then if dat is not 0, I won't have gone through the jump and gone back there. So I will move ac, whatever state it is, first 100 to P1, then I will not it, so change it to 0 for the next thing, and then I want to sleep 1, and I want to jump loop. That sounds right to me. AC 100, P0, 0, right. Do I need to move something to P1? I think it just, like, sets... Okay, so... Does it hold its previous value here? Or am I gonna, like, leave it on 100 after this? That's my concern. Yeah, okay, I think it's gonna leave it on 100 after this falling edge. I think that's what's going to happen. Okay, so 0, 0, 0. Sleep, jump to start, get ready to pulse. Okay, so disabled. 100 goes to P1, yes. 100 turns into 0 in AC, yes. Sleep 1, jump loop. Okay, read state of button. Button's still down. 0 goes out. Alright, as expected so far. So advance, I'm guessing, just goes by 1 time unit. Sweet. Okay, so now, move P0 dat. That's now enabled, so it waits. Great. Alright, this will work the same. This is the same thing, just a slightly shorter pulse, but the real test is coming right here. Do I have the bug? I think I do. Sleep 1, jump start. Yep, okay, got it. So that's easy. Here's what I do. How does that sound? Didn't work. Why was P1 still 100 at that point? Wait, I slept first. I want to not sleep first. Can I cut and paste? Oops, I can. Great. Okay, so write to P1 before you sleep, and then it'll work. Perfect. Okay. I did it. Can I go faster? No, that's as fast as it goes. There's a profiler. Oh, I see. The instructions that spend the most... Oh, that's cool! What a simple but highly effective profiler. I love it! Yeah, so hotspots, places where the most CPU time is used. That's pretty well balanced. I mean, of course this would be the hottest spot, but it's not that much hotter than the rest. Great! Whoa. Production cost, really? Much more common to have done it with one MC4000. Okay, so there was a way to do it without the extra state that I stored. Oh, could I just use tech on P0 instead of storing it in a register? I'll bet I could have. Right? Hold on, can tech be used like that? Yes. Okay, that's what I should have done. Should have used it on the pin register instead of an internal register. That's what it was, but a lot of people made the same mistake. All right, I learned. Power usage, yeah, it's kind of high. Would have been lower because I wouldn't have had to move and then test. Well, you know what? Continue editing. What if I change that? So give me an MC4000. Your P1 is there, your P0 is here. Okay, yeah, so I just want to cut, paste. Okay, fine. So, 100 AC, loop tech, P0, 0. And now you're going to fit? Yeah. All right, great. How's that? There we go. Okay, I made it more efficient. And this will use less power. What's the profiler look like? As expected. Excellent. Whoa, okay. It resets. And then it zooms. All right. That's better. Power usage could still be lower. Okay, I wonder what I did. Okay, so fewer lines of code. What's wasteful here? I have sleep 1 twice. Okay, got an idea. Can get rid of this move and do the not first. Why am I optimizing this? I don't know, it's fun. Yeah, so if I not first, that'll just default to 0. But no, then it won't reset, will it? Sleep on, okay, so I have to, no, I don't want to go this far. It's fine as it is. I'm satisfied with this solution. It could be optimized further, and a lot of people did, but I'm not going to do that today. But I mostly understand how... Ooh. That's like logic gates. Looks like fun. Okay, I'm happy. That is sufficient for me. I haven't yet chosen a favorite axis of optimization. If I were to guess, I'd say it's probably going to be power usage. Yeah, it's almost certainly going to be power usage. But we'll see how that actually ends up being. Yes, looks okay. Suitable for our purpose. Okay, good stuff. All right, I learned a little more. I did one more project. Next time I'll probably try the solitaire and see how it goes. And oh boy, got a spam email. Fantastic. All right, I'll read my spam box next time. I'll see you then.